In this video, we continue to see strategies for finding determinants of matrices, and we are going to see how to find the determinant of a triangular matrix as our learning objective. All right, so here is one way you can find the determinant of a 3x3 matrix by hand. It's a common shortcut. So you start with your 3x3 matrix here, and then you recopy columns 1 and 2 so that you've got your matrix with columns 1 and 2 augmented. They're the new columns 4 and 5. And then to calculate the determinant, you do these multiplication along the diagonals. So you add what I'm going to call the downward diagonal multiplication products, and you subtract what I'll call the upward slope matrix diagonal products. And so the result here is this formula A11, A22, A33 plus A12, A23, A31 plus A13, A21, A31, which is just what you would have gotten if you'd worked through this kind of cofactor calculation. And you can see if you just distribute these values through, that these are actually corresponding in our calculation we did earlier, and you distribute through with those same entries that we had. And then you subtract out A31, A22, A13, A22, A23, A11, and A33, A21, A12. So here's an example. If you've got this matrix 1, 1, 3, 0, 4, 6, 1, 5, 8, you recopy columns 1 and 2 over here. And then as you go through the downward or the negative slope calculations to add, let's see, 1 times 4 times 8, that's 32. 1 times 6 times 1 is 6. And 3 times 0 times 5 is 0. So our first calculations here are 32 plus 6 plus 0. And then on the upward diagonals that we're going to subtract out, 1 times 4 times 3 gives us a 12. 5 times 6 times 1 gives us a 30. And 8 times 0 times 1 gives us a 0. So these are the values we subtract out, and we end up at -4. So for a 3x3 matrix, it's kind of a toss-up if you want to calculate it this way or use SIMPy. Let's go check it out if we put these values in SIMPy. So I'll call this matrix A. We got 1, 1, 3, 0, 4, 6. And 1, 5, 8. Verify our matrix A. Here's a match. And then you could do determinant A. And you get the same result, or A dot determinant. So it took me about the same amount of time to enter my matrix in SIMPy as to recopy the first and second columns and then go through the diagonal calculations and add up and subtract out the upward diagonals. So your choice, which way you like to do it, it can also be how close you are to a calculator or to SIMPy. Okay, this brings us to theorem 3.2, which is a theorem about the determinant of a triangular matrix. So the determinant of a triangular matrix of order n is the product of the entries on the main diagonal. So think about that, because you know you've got zeros in either the lower part or the upper part. And so think back to our visualization here. If you've got zeros and you go through these multiplications, you're going to get some cancellation there when you try to go through a process like this because of zeros. So our proof is up to by induction. So we'll do the proof for upper triangular matrices, and then the proof for lower triangular matrices is similar, and you're welcome to give it a go on your own. So we'll start with the k equals 1 case. Well, then A is just a matrix with one element, so the determinant is that element, what we call A11. And then we're going to assume that the theorem holds for all upper triangular matrices of order k, and then we're going to let A be an upper triangular matrix of order k plus 1. So then if we expand that last row, taking the AK plus 1, k plus 1 entry down here, that's going to get multiplied through by the k by k determinant, and so that becomes the a k plus 1 by k plus 1 entry multiplied by the product of all the diagonals, right? Because this is a triangular matrix, so we're just working with the diagonals. And so then we get the same product with the a k plus 1 multiplied through. Right? Does it make sense, everybody, why this entry here is just a to the k plus 1, because we've got zeros everywhere else in the row, because this is an upper triangular matrix. So if you were doing the proof with a lower triangular matrix, you would use probably the column values there where all the zeros are going to be. Okay, so very simple proof, and we see that to calculate the determinant of a triangular matrix very, very quick. And here's an example. So here is my lower triangular matrix. So to find my determinant, I'm just going to multiply the diagonals here. And, you know, if you wanted to use our other method and try to recopy some of the rows and see what happens, this is a 4x4, so you'd recopy the first probably 3 columns. You would start to see, oh yeah, as you go through those arrows, let me show you what I'm saying. If I try to recopy this, and kind of start to draw in arrows to show the multiplication, you can see, oh yeah, things are going to start to give me zeros everywhere else because of the triangular form. You can see only the diagonals are going to actually work out to be a product that's non-zero. And so if we multiply the diagonal values, we get 2 times -2 times 1 times 3. That gives us a -12. And you are welcome to verify that result in Simpy. All right, so we're going to look more at determinants and some elementary row operations corresponding with determinants in the next section. But that's it.